Hello everyone, welcome to this coffee break. So today for tubing, we're going to talk about Magnifi. So I know Magnifi has been around for a lot of time. Many of you use it. It's your everyday software, and it's packed with features. Whether you're doing a surface or tubing, we got you covered with Magnifi. Over the past few years, we really put a lot of their efforts. For us, we see Magnifi as something very important for your everyday job. And anyway, in the way we see this is your hardware, the octane is very good, but it's going to be as good as your software. So we do value the software. We do want to put effort in it, and we do continuously add features to it. So that being said, I just thought that I'd take this opportunity of the coffee break to discuss a little bit, few ones. It's on the surface. So these will be a starting point, a few features. But if you want to know more, if you have ideas, if you have things, reach out to us. Let me know in the chat. Maybe if it's not in this session, maybe we can do another one. We really like to get in touch with you, the users, so we can transfer all the knowledge we have of our software, so you can use it and be more efficient when you're on the job site, especially on the tubing job. Maybe some of you have just finished turnarounds or have some upcoming up. We know time is tight, so we want to make sure that you get the job done well, but efficiently as well. So without further ado, I will switch to my screen. I don't know if I can do this myself. Here we go. Okay, so first one. One trick that is really nice and really easy to set up is the landmarks detection. So if we go in setup in the landmarks here, we can automatically detect the tube sheets. So this it's an extra step in your setup, but you could save time doing this. So first off, you need to choose the raw absolute lowest frequency possible. Then reporting, it's up to you, whether it's from start reporting or stop recording. Personally, I like the 0 to be right next to me at the tube sheet. So we got the little diagram here, and one that is important to choose is the detection engine. Legacy is the older ones, but we got a new one. It's called the extended. This one is a little bit better. We've worked on the algorithm, so it's good. And after that, you only need to have the tube sheet 1 and tube sheet 2. You can name it whatever you want. Make sure it's enabled, and once it's done, you click on next. So because I changed my setup, I'll go back to reload my data. Then what I need to do is only calibrate my landmarks. Sorry, the window is on the other side here. I put my cursor here. So this is going to be my tube sheet 2. And here, my tube sheet 1. Click on calibrate, and that's it. So if I zoom out, previous zoom, I see that my tube sheets have been identified. And here you go. Every time I switch data files, I'm going to look at another one. They're going to be automatically detected. What it is good for, easy for you. The one thing that is really nice about this is that your defect positioning is going to be more precise. Even when you're doing manual pulling, it's going to be time-based. It's an approximation, but still, if you put the markers like this, it's going to be a better approximation. And once you import this data in TubePro, if your position is good regarding the tube sheets, then your 3D model will be more realistic. So that's a nice feature. So if you want to bring value to your customer, make sure that your defects are well positioned. Always handy to have the landmarks detected. Next one is again with the landmarks, but this time is going to be the manual sequence. We have a feature in Magnifi that you can start and stop your acquisition automatically without touching the screen. So if you're on your own, want to be really efficient, so you go back to the same. What we need to set up is that the exit signal from the probe. I will show you if we go again to the landmark. This time we'll set it up a little bit differently. So we're going to set up the exit to during what it means is when it's in acquisition. So when you're going to press acquire, then the algorithm is going to look for the exit. The exit will be, you are going to start the record, well, the data refresh once the probe is inside the tube. Once it exit, then it's going to detect it. That's going to be the first detection. Then the other one, so here is the exit. So the probe is going to exit the tube sheet. It's going to be at the other end. Then what the probe is going to see is going to be, see TS1, so tube sheet in. So the probe going in. So we need to make sure that we name this one to TSI. And at the very end on this diagram, the probe is going to scan the tubes. It's going to go to TS out. So the probe is going to come out of the tube sheet. And we're going to see this. We're going to call it TS out. Oh, sorry, like this. Okay, so we're back. What we need to do is then set up those landmarks accordingly. In this case, so this one is going to be tube sheet. Oops, no, I need to go calibration, manual sorry, one step to landmarks. So this one is going to be tube sheet in, so it's going to be a little bit different. This one is going to be TS out, like this. I'm going to refresh. Tube sheet in. If I remove all landmarks, okay, I'm going to tube sheet in like this. I'm going to set it. Then again, tube sheet out, assign it, calibrate. It gets mixed up. Oh, it's the way. Okay, anyway. So for this, you set those. And the last signal you need during your calibration is the exit. In this case, it's not going to work because the data, I don't have it, but I'll show you a little video. Once you set up those landmark, you can do the manual sequence. In sequence, you open this thing. So there, you set it to landmark. You're going to start recording at the exit. You can add one. So once the probe is going to detect the exit, you can add a delay. So let's say half a second. So you're going to come out. It's going to detect that it's coming. The probe is out. It's going to start the recording. Then you're going to go through it to the landmark, the first tube sheet. You're going to have all the data. And once it's out at the other end, you can add a little bit of extra data just to make sure that you have everything. Add. And it's going to stop the recording at the other end. Then it can wait. Or what we like to do is put a timer. So this is the time between you stop at one acquisition and you switch to the other tube. We leave about a few seconds. In this case, I'll just put 3 seconds. If you some settings are not correctly, we have some warnings, so we enable, and this one is just asking me to connect to the computer. In this case, I do not have the thing with me as I'm at home, but I have a little video to show it to you. So in the screen, you will see what I mean. So this is data that was acquired with the manual sequence, and I will stop it here. So after an acquisition, you see that the data on the screen is displayed at the top. Sorry, I cannot say here. So this is the exit signal that I see. Then it waited. Then the green is that the acquisition has started. It detected the tube sheet in, then the tube sheet out, and it waited. And in the menu here, you see that I have a waiting for the next tube in green. So this is going to be my 3 seconds before I move on to the next tube. So I'll let the little video run so you can see it in action. Now starting next file, exit, starting the acquisition, scan the tube, stop, and then I have my 3-second pause before I switch to the next tube, like this. Like this, and again. So this, very handy if you're on your own, you want to speed up your acquisition process. You just to make sure, the one trick is make sure that you set up those exit signal and landmarks, this data from an actual speed of recording. So make sure that once you set up those things, you're at your normal speed for your acquisition. Next one up I have here is shortcut. So we call this for calibration. So what I can add is, if you want to calibrate support plates or through hole, this could be handy. In the calibration, we just click auto click, we add it here, and whether it's a landmark or a channel, you can set a shortcut for it. So for example, if I wanted to quickly calibrate my support, it's gonna add me a default keyboard shortcut. So this one is Alt1, and I click OK, and now I will have a new shortcut here. So whether I go in my strip chart and I see this is my support, I can add it here. So this is I could click on Alt1 to calibrate, or I can click on this shortcut here for support. So this would calibrate it. So this is very helpful. Next one is going to be the undock the tab, the report tab. So at the bottom, you know, once you're acquiring your data, adding the defects, the report is normally at the bottom. Which, oh, sorry, 1 second, I'm going to pin it down like this. Hit it. So here it's stopped here, so it's there, but I'm kind of taking on the screen of my thing of mine. So what I can do, and currently I have 2 screens. I'm not sure it's going to be show up, but what I can do is that I can undock this report tab, and imagine if I would be on my second screen at home. I just move it out, and now I have it full screen on my second screen. So this is very helpful. So you're up now. All you have here is your data that you're acquiring, and on your next screen next to you, it's the same report tab, but it's undocked. So I have a list of like 35 tubes that are filled in there. Much more information that it's available to me, and I can simply close that if I want to. Next one, we're going to move to array data, so Magnifi. So the Eddyfi. What we have here is the data acquired from a real inspection on the Eddyfi. You see on the right, this is a data that has been filtered. So we played with the filters. We kind of make it really good, etc. But still, if your settings, filter settings are not set properly, you could miss a defect. This one is clearly very visible, but you can see here on this one here, this is the unfiltered data. That's the data once it's coming out of the exchanger. We have one tool that could be very helpful to do this. It's equivalent of doing a null or a balance. If I go here, if I go here and I see my baseline is a little bit different, we're going to zoom in. I can add what we call the subtraction cursor. So if I add it here, I'm going to activate the horizontal subtraction here. So I'm going to remove this and I'm going to close. And my subtraction, it's going to be in the blue. Here is my cursor. So I can move it. And what it does, it's simply balancing the data close to my cursor. So it's doing an average. So it's the equivalent of doing a balance to it. And we see that the data is much more clearer close to the subtraction data. So we are better at identifying the defects. Once I'm done, I can simply drag this cursor, and this cursor is independent of the your normal cursor for identifying the defects. So if we place it here, we have it like this. And if I'm done with my cursor, I simply remove it and I put it in the black section. And now it doesn't do, it kind of resets the cursor. So it's there, but it's not activated. It's only once I move it to the data that now my data it's much better close to it, and I can better identify the defects. And finally, my last little trick that I want to share. I have a question here from about Magnifi. So this is version 4.8 revision 20. So that's the latest that we have available on the website. Here, when we're in iris data, it could get tricky to find the deepest point. So what we have is it's a little tool. So what we can do is from data, that's kind of one of the layouts we have. I can change one of the views to what we call info fields. So in my layout, I can replace one of the view to info. So I can click on the wish, and then again, I'm going to click on the view that I want to change. So this is going to switch. So now it's white because it's got nothing in it. But if I go to the current view tab, I can add information there from analysis. In this menu, I have a lot of things that I can choose from. This one is going to be for iris, and I want to have the minimum wall thickness. No, sorry. Cursor, UT. No, sorry. Scan wall thickness. No, okay, here it is. Sorry. So the C-scan minimum wall thickness. These are one that you want to have to see, and I can put the C-scan max wall loss as well. And maybe I can minimum wall thickness on the C-scan that I see, or wall loss, etc. So I can choose the information I wanted to display. I'm going to click OK. And now my view is going to be updated with this information. The one trick, so the C-scan max wall loss and the minimum wall thickness are linked to the data that is shown on the C-scan. For example, and then if I click on this button, so because it is a small arrow triangle at the bottom, it means that these fields can be clicked. So if I click on it, my cursor is going to move right to the C-scan max wall loss in percentage. So here, let's say I have 39. And if I click here, boom, it's going to change again. Okay, this one is a bit too big. But if I have a region that I want in particular, that I think there is my defect, I can zoom in, and if it's difficult, I click again, and now my cursor is going to be centered. So it's always referred to the data that is shown in the C-scan, and this is where you click. You can click to access it. So very helpful. And this button, if you have them also in your A-scan, you can click and change it as well. Okay. So that's for the info field. So these are the small tricks that I wanted to share. I think there's a few questions in there. So I will go up there. This one, David, for iris inspection, can we also edit the info shown at the top of the A-scan? Yes, of course. So in the A-scan here, it's the same thing. So if I click here, the orange is around my view. I can click on info field in the current view. And the boxes that I have here, it's the information that I can display. So again, if I want to add more information, I can simply add it or remove them from here. So whether it's a circumferential or actual, whatever. So we got a lot of things we can set up and you can choose from. And then if I go back here, iris, maybe outside diameter, okay, I'm gonna add them, and this information is gonna be shown again here, added. Same if you want to remove, then it's gonna be easier. And those ones are not very easy to find or see, but these one, you see that once I go over it, I over it, they move a little bit. So that means that these ones are also clickable. Sorry for the user interface. It's not easy to understand, but it's the same idea behind those black triangle. If I'm here, I click here, it's going to move it. And if I'm here in this view and I click on this, it's going to replace my cursor to that location. So it could be very useful. Next question. I heard that sometimes tube sheets are not correctly placed. What should someone do in this case? Okay, if we go back to ECT data, so if we have it here, in this case that we have one tube sheet here, for whatever reason, even though you're in, you have two things first. Well, the first one is going to be you can recalibrate the tube sheet. So if you see that it's offset a little bit, then you can go and calibrate it again. You can also set a new calibration shortcut. So we could do this way. Add one for landmark, then pick up landmark, TSO or TSI, and I can do this very quickly. Other way around, honestly, is simply to move it. We know this tool is rule-based. It's not perfect. It does a good job, but sometimes once in a while signal is crooked. People have slowed down in the tube sheet for whatever reason. So we can simply take them, drag and drop, and it's gonna change the positioning of the defect at the same time. And honestly, and then keep an eye out for this. We're working on things. We want to improve this. I think there's a lot we can do there. So in the future version, we're starting to work on improvements of those detections. So stay tuned for this. This can be really good. Do we have another question? The large number that showed with iris, I think it could be useful. Such display for an acquisition setup. Is there a way that we have that in other setup, not just iris? Yes, of course. Same goes for ECT. Got the data here. I got my layout. I can replace this view. So if I go, I want info field, I'm going to replace my mix there, and then select this view. And again, I can choose information that it's going to be shown, whether it's from during, oh, sorry, it's on the other screen. In acquisition, now the information is not going to be shown because I'm there, but it could be the position in X, the time, etc. So if you add them, this one will be shown during acquisition, and during analysis, it's going to be, again, if you want to show information regarding the channels or just general information. This could be helpful if you you want this and add to this information. And I know most of you add screenshots to your reports of your data. So whatever information you want it to be displayed, that could be helpful to get that. Just wonder if there's another section. I see which reference technique for interpretation. Not sure what you are referring to here. So if you're still there, Satish, I'd like a little bit more details on it so I can answer it properly. But I see that a lot of people are around the world, so thanks for coming out. And again, if so when you do calibration, it says failed or error. How could you correct it? calibration is two things. Normally, once you, I do not have calibration data on this screen that is shown, but normally what will it fail? It's the sizing curves. So if we go to system calibration, we're gonna assign the values. For example, here I could choose my defect that are found in my calibration tube, and then so these are the points that are going to be used for my calibration. So then I can calibrate my sizing curve, and most of the time it's going to be the sizing curve that it's going to fail. We could look at this for quite a while. We could discuss again, but sometimes when it fails, we always advise to click on view curves. If you click on view curves, you will have those curves and the dots. So what we want nice lines. This one is a little bit off because of that defect. It's not able. So what happened is that the system is not able to draw a line to set those calibrations. So this one is a nice calibration curve. And once you see calibration fail, it's probably that one of the points is a little bit off and it doesn't make sense. First thing we can do for a point, sometimes it's that it's too far out, so we can move them manually. Of course, it's not really, but I would just want to show you that this is what that could be. So what we want to do is make sure that it's there. So you got a few things you can play. You can play with your frequency. You can reassign the values, rescan your tubes, make sure you rebalance also. So just restart a little bit the calibration process. That can happen. And sometimes these are vector measurement. So sometimes the computer misinterprets the angle from a 180-degree difference. So sometimes we just need to redo the calibration, and it's gonna pick it up. So again, if you do your calibration and you got an error message, click on view curves and validate that this information. So this one is not good because this point is there. So the 4x20 flat bottom holes, there's something there. So maybe you want to repull the calibration tubes and verify the information. But I think this one, the phase angle might be a little bit. And what we can do, here it is, we can invert it. So you see that the phase angle, it's really different from the other ones and it doesn't make sense. So we can invert this data. And now my calibration is back to being normal in the value. So what happened is that the angle was 180 degrees off just because of the direction. So if we click, a quick tool is that we click on invert and bring it back, and you see now that my calibration curve is okay for the differential 180. So is there another picture question? No, I think we're good. Thanks. Yeah, as you see there, reach out to me if you have more questions. We'll be happy to hear from you, see what we can improve, and also learn from the good sides of Magnifi. Tell us what's working good, how it does on the job site, and thanks. Thanks for everyone around the world. I see from people from India, Indonesia, and the US. I hope you guys like it, and we'll stay in touch. Take care. Thank you very much.